So this would be the load combination that we're going to punch in on our model, no? So you have your allowable stress design combination, and then the ultimate load combination by LRFT, no? The load resistance and factor design. We also have the basic load or alternate basic load combinations, no, as prescribed by the code. So you may refer your load combination on this section of the code, section 203.3.1. No? So pag-aralan natin yung load combination, no? So you notice that 100 plus for service and then 200 plus for ultimate, no? So I'm doing this notation for my practice. Okay? So may mga load combination na hindi rin lang mag-govern dito, you can take it out, no? Just like for example this 101 comparing it to 104, no? Dead load, and then you have your live load 1 and then 1, no? And then ito naman 0.75 dead load, 0.75 roof live load. So you can remove this one, no? And then retain 101. So let's go back to STAAD. Okay, so load case 1, 2, 3, and then it follows the numbering. Again, do not try to renumber this one, no? That would be the job of STAAD already. Okay, so we go with 101. Ayan. Dead load plus live load. So select these two, put it on the right side, and then yung factor niya, no? Just follow the notation 1 and then 1. You had it? So I'm done. Okay, and then you have 102. Now, so 0.75 dead load plus 0.56 roof live load plus 0.34 wind load. Okay, so get the 3 and then just follow your numerical coefficients there, no? 0.75 going to 0.56 and then 0.34. Okay, you had it. And then 103, 0.45 dead load plus 0.45 wind load. Select 1 and then 3, put it there. 0.45, 0.45. Okay, so kompletuhin nyo, no? Kompletuhin nyo. You need to complete the setup. So this would be a tedious work if you will be repeating this one from time to time. So ang ginagawa ko dyan, okay, so I will complete the setup. You go to the STAAD editor, just hit save, and then select this one, no? Until the tanggalin ko muna ito. Until the load 1, no? Control C. Okay, then right click, you have a new text document. You paste it, na? And then try to remove these parts, na? Okay, so ayan, load 1, load 2, load 3. Tanggalin mo na lang muna yan. And then load combo 4, load combo 5, load combo 6, no? So you just need to complete the setup. In my case, ito, ready-made na to, no? So all I need to do is just copy this one, no? Tapos ko na to, na-punch in ko na yung load case 1, load case 2, load case 3, no? But you just need to complete, no? And then you do it this way. Okay, so para matapos ko to, no? I'll go back to the STAAD editor. Tanggalin ko muna yung load combo na to, no? Okay, so you have the load combinations na. So I will just hit close. And then yes. Okay, so andun na, no? So tapos na. Tapos na yung load combination natin. Okay, so paano basahin to yung mga load combination dito, no? Okay, so let's go with an example. Again, dead load is your load case 1, so andun yung 1. Okay. Live load is your load case 2, so andun yung 2, and then this would be your numerical coefficients. No? Another example, let's say this one, dead load is load case 1, win load is load case 3, and then ito yung mga numerical coefficients. So, load case 1 and then load case 3. 1, andito yung 1, and then 3. And then the numerical coefficients. Na? So, ganyan magbasa if you're typing this one in a text file. So, close and then save. Then, tapos na natin. No? We're done with the setup. You just fill in the necessary information for your report. Geometry. I've given 3 ways on how you're going to model your geometry. And then general, ito yung matrabaho, no? So you have the property, specs, support, roles and definition, yung kagagawa lang natin, no? And then the material, of course. And then we go to the 4th stage, no? Which is the analysis sprint. This is just a prerequisite for the design. Okay, so I will hit analysis sprint, and then I will add without no print, no? Add. So take a look at this one. There is a perform analysis as listed by STAAD. Okay, so I will close this item. Now I will tell STAAD that he will just select my load combination I have punched in a while ago. So I will go with post print and then define command. You get this one, all, you put it to the right, and then add. Okay, so under the analysis sprint, there should be a perform analysis and then your load list. Okay, so this dictating that STAAD, this will be your load combination. Okay, so I will close this one now. I will go with the design. Okay, so you have your steel. Again, you have sub pages, no? So we're under steel. You have concrete, timber, aluminum, and then shear wall. No? So we go first with design under steel. Okay, so if you go to the data area, the first thing you should do there is to put up the code you're going to use. No, so in our case, I will put this one to AISC and then ASD. Okay, so yan yung code na gagamitin ko. And then you go with the defined parameters. Tatlo lang yung i-define mo dito, no? The yield strength of your section, okay, which is the A36 248 megapascal. So, ito naka-arrange to ng alphabetical order. You go with FYLD. Ayun. And then the yield strength. Okay, the yield strength is 248213, no? But again, let's put that one to 00. Okay, 248 kilopascal or 248,000 kilopascal or 248 megapascal. I will add it. Okay, so it's added, the parameter there. And then our design, no? Our design checking would be your ratio, no? So this is the ratio. The ratio should be equivalent to 1. If that is greater than 1, then we're overstressed. Okay. Allowable divided by the actual stress should be less than or equivalent to 1. Now, permissible ratio of actual to allowable stress, you set that 1 to 1. So that would be our checking if any member of this model would be failing. Okay, so hit add. So that would be ratio there. And then you go to your track, no? On how are you going to print up your report, no? Track 0, print the design output at the minimum detail level, and then track 1 would be intermediate, and then track 2 would be the maximum detail level. Okay, so I will just go with track 0, no? So I will add, close, and then I will command now STAAD. Just hit yes, now save this one from time to time. And then check code. Okay, so STAAD, you command STAAD that no other code will be used except for AISC ASD for our model. kung ito yung pinili mo. So, you just hit add. And then, if you're estimating and if you want to get the weight of the members, no? Because this is not part of the loadings that we have, you go to your member takeoff, okay, or the takeoff. So the difference is that it is here, the description provides a tabular report of the total length and the weights of all sections used in the structure on a member by member basis. So all of the member will be listed. And then for takeoff naman, this is just a summary, huh? Weights of all sections used in the structure. Okay, so I will go with member takeoff and then add and then close. Okay, again, we go to this part. The question mark would be unassigned. Lahat ng mga naka-question mark is unassigned. So we select and then assign this one to the whole structure or assign to view. Again, be careful on assigning. STAAD, no? Assign to view again. Check code. Assign to view. Yes. And then still member takeoff and then assign to view. Okay, so after we are done, no? From setup geometry on this page control, no? General, analysis, print, and then the design. We are now ready to run the analysis. So before analyzing, we go first with tools, no? So you check for duplicate nodes, okay, 0 tolerance, 0 meter tolerance, no duplicated nodes. You go with tools again, check duplicate members if you have a duplicate members, no? Especially if you have so many members that you have modeled on your workspace. Okay, so we're done checking that one. You go with analyze and then run analysis, or that would be control 5. Control plus F5 is the shortcut key. Or never mind, I will just analyze, then run analysis, and then save. You wait for STAAD to generate your reports and the design, no? So there is no error or warnings or notes, no? I will hit view output file and then hit done. Okay, so this would now be the report of STAAD. So if you go with the results on the left side, you go to the steel design. Let's try to study, no? This one. Okay, so you have member 1 with the section of 2 by 2 by 3 out of 16. The remark is passed. Okay, so this member receives a 7.26 kilonewton in tension. And then the permissible stress, no? Actual divided by allowable is 0.64. Okay, so it's less than 1, so it's passed. Okay, so how about here? Member 16. So it receives a force of 39.4 kilonewton in tension. And then the demand to capacity ratio is 1.279. So this is failing. Okay, so that's how you read your this report. Now you go to the steel takeoff. Okay, so again, this is a member to member, no? So member 1 has a length of 1 meter and then the weight in kilonewton, so 0.072 kilonewton. So you have 37 members. The total weight is 2.012 kilonewton. Okay, so this is the summary. If you try to take a look, this is the summary. Now, so the total length of the double angle would be 20.77 meter if you're estimating. So this can be your guide. And then for the web members, okay, for the single members, you have 21.61 meter, and then the weight is 0.526. So if you add that up, that's the same as 2.01 kilonewton. Okay, so the next one the next thing you do would be you go to the post-processing. Okay, so again, you try to run all this one. Dictate STAAD that STAAD will run all the load cases and then the load combinations that we have applied. No? And then hit apply, hit OK. Okay, so after that you go to the beam, because again this is what we call beam in STAAD. All of the members that we have modeled is called beam STAAD. No? You go to the beam and then tick on the utility check. Okay, so those who are at the green one is passing, no? And then those who are at the blue one is overstressed, and then on the red one it's very overstressed. Okay, so red mark, overstressed na yan. 1.51, the demand to capacity ratio is 1.51, so 1.51. So we have a failing members now on the top cord, and then the web members here. Okay, and then almost identical, no, or symmetrical. Okay, so what you can do is adjust, no. You can go to the modeling and then adjust your properties, no. So you can, the top cord is the one failing here, so it's up to you to navigate this one already. Either you put another section, come up with a greater thickness, or you can put the web members are as a double angle also, no? Or we can make use of this command by the STAAD, no? So the STAAD will choose the section. You go with the design, okay, and then command STAAD that he will be the one to select, no? Select optimize is the command, no? Select optimum section size for all members using procedure consisting of multiple cycles or iterations of analysis, as well as as iteration and section sizes until an overall structure list weight is obtained. Okay, so the weight is the basis of this select optimize by STAAD. Okay, so we now try to add, okay, and then run again the analysis. And then do you want to proceed? Yes. And there is an error here, warning, and there would be one warning here, no? So let's take a look at that warning. Okay, so go to view output and then done. You go to this warning, pinpoint to that one. Okay, so some member sizes have changed since last analysis, because on the first one, on the first analysis, we come up with our section. We put the section and then analyze. And then on the second analysis, STAAD now will be the one to choose the section. So this is just okay. Okay, so you go to the post-processing and then beam and then utility check. Okay, so all of them now are passing. Pero ito, be careful kasi tingnan mo to, no? Be sure that this should be at a single size. The top cord here should be at a single size. On the windward side, so should be a single size, and then as well as the bottom cord. Okay, so if you take a look, this is member 1, 2 by 2 by 2 out of 16. Okay, and then member 2, 2 by 2 by, ayan, hindi nagbago, no? Until here. Okay, but how about this one? At the top cord, you have a section of 2.5 by 1.5 by 3 out of 16, so mas makapal. And then member 12, iba na naman to, no? It becomes 3 by 2 by 3 out of 16, no? So either you choose just one, no? Be careful on this select optimization of STAAD. Okay, so that's how you design your steel truss by applying method 2 of the analytical procedure of the NECP.